and compounds. All right, so just to remind you, molecules and compounds. A compound, remember a compound is a pure substance. Remember when we talked about matter, we broke matter down into either a pure substance or a mixture. And we said our pure substance is either going to be an element or a compound. We've talked about the different elements from the periodic table. And compounds are just basically when you take these elements and they are chemically combined to one another. And the way they are chemically combined to one another is they use what is known as chemical bonds. Biochemical bonds. Now we have different types of compounds. And we're going to talk about the different types of compounds and then how we name these different types of compounds. But just an example, you know, water, for instance, is a compound, and the formula for water is H2O. So when we talk about compounds, we represent them with what is known as formulas. And I want to go over a couple of different types of formulas. So we have what is known as an empirical formula. The empirical formula is an important one. And an empirical formula basically just gives the relative number of atoms in a compound. And all this really means is the empirical formula just gives you the ratio of atoms in a compound. And we can also have what is known as the molecular formula. And the molecular formula gives the actual number of atoms of each element in that compound.
Professor, can you back the camera up a little bit so I can see the definitions?
Is this better?
Yeah, thank you.
See right there.
All right, so One gives the actual number, the other one gives the ratio. So let me give you an example of what I mean. So my example would just say, for instance, let's think of hydrogen peroxide. Hydrogen peroxide, most of us have this in our bathroom cabinets. Hydrogen peroxide. It has the formula, the molecular formula of H2O2. And all this means is there are 2 hydrogen atoms for every 2 oxygen atoms. And so this is the actual formula for hydrogen peroxide. We say that this is the molecular formula. But as we see the ratio of hydrogen to oxygen atoms is 2 to 2. So we can simplify that and say, oh, that ratio really means it's just 1 to 1. So for every 1 hydrogen atom, I also have 1 oxygen atom. And we say that that is the empirical formula. So basically the empirical formula is just a simplified version of the molecular formula. So for example, if I said, here's a compound C3H6O9, and I wanted you to write the empirical formula for this compound. Can we look at this and see what the empirical formula is?
CH2, CH2O3.
Okay, so what we'd have to figure out is what do they have in common? And so what they have in common is that, okay, they all have a 3 in common. So I could essentially just divide all these by 3 and still get a whole number. So what this would really say for my empirical formula, it would be 1 carbon atom for every 2 hydrogen atoms for every 3 oxygen atoms. And this would be the empirical formula. So I heard some of you guys say CHO. The only issue is we have to set up the ratio between each element, not just which elements are there. We have to set up the ratio between them. Just like here, the ratio here is they both have 2. So if I simplify them, it's like I divide both of these by 2, it gives me a 1-to-1 ratio. But
So
in this,
I'm sorry. So we're always dividing. Is that what you're saying?
yeah, we're just trying to find like the common factor, like what number they have in common to
Okay.
simplify it to. Okay. All right, so another type of formula that comes up is a structural formula. A structural formula basically just gives you the layout of the atoms. We talk about structural formulas a little bit later. So we can also have a structural formula. Structural formula. And it's just, it gives a layout of the atoms. And if I go back to the hydrogen peroxide example, it just says which atom is connected to which atom. So remember, I said hydrogen peroxide has the formula H2O2. And so by looking at this formula, you guys might think, oh, okay, both of the hydrogens are next to each other and then both of the oxygens are next to each other. But in reality, the structural formula for it shows that hydrogen is connected to an oxygen's connected to another oxygen, and then that's connected to a hydrogen. So it just shows you which atoms are bonded to which. And we'll talk about the structural formula later on in the semester. So basically what I'm saying is when you talk about compounds, you have to write the formulas for them. These are the different types of formulas. The main formulas we're going to use are the empirical or molecular formula. And we're going to talk about how we write these formulas. So if I go back to compounds, remember we're just using the formula to represent a compound. We have different types of compounds. All right, the first type of compound we have is, well, the first one I'm going to talk about is an ionic compound. All right, so an ionic compound, it's just what it sounds like. It's made up of ions.
Made of cation or anions?
Made up of a mixture of both. So it's any type, it's not any type, but it's ions that are bonded together or strongly attracted to each other. So the way we say it's composed of ions, and remember all an ion is anything that has a charge, whether that charge is positive or negative. So we say it's when a positive comes together with a negative. Like opposites attract, we need a positive one and a negative one for it to work out. Most of the time, it's going to be in the form of a metal. Remember, metals are going to form positive cations, and non-metals form negative negative ions, which are anions.
So metals are positive and non-metals are negative, right?
So it's like positive, negative.
Okay.
Just to remind you guys, where's my periodic table? Here it is. Just to remind you guys, if we look at this periodic table, remember I put the charge at the top in orange. The metals on this side, they form the positive signs. And then when you go over here to the non-metals, they're going to be the negative ones when they form ions. So it's basically saying when you have a metal and a non-metal together, and it's more than just that. So the real definition is just when you have a positive and a negative, because sometimes it's not just metal and non-metal. Sometimes it's just a positive and a negative. But it's composed of ions. You end up, it's what happens in ionic compounds is that they transfer electrons. When they transfer electrons, we call the base of it a formula units. So let me give you guys an example of an ionic compound. One example of an ionic compound is table salt. Like table salt we have at our house. The formula for it is sodium. When sodium ions come together with chlorine ions, they form the compound NaCl. So sodium is in group 1. So it's going to have a +1 charge. Chlorine's in group 7. It's going to have a -1 charge. So when they come together, this positive and this negative are attracted to each other. They're strongly attracted to each other. And what this means, remember, the positive sign means I'm missing an electron. The negative sign means I'm gaining an electron. So what ends up happening is they're transferring electrons to each other. One's losing one, one's gaining one, and they end up having a neutral compound, and it's called sodium chloride. Now, which brings me to how we figure out the formulas for ionic compounds. So this is a whole section just writing formulas for ionic compounds. Sorry if the screen gets blurry, it's raining pretty tough over here. All right, so we are writing formulas for ionic compounds. So anytime we want to write a formula for an ionic compound, we basically have to know the charge on the ion. If we know the charge on the ion, writing the formula is pretty simple. If we don't, we have to do an extra step. So let's say I have an example that says write the formula when aluminum ions are mixed with oxygen ions. So what we have to do first is we have to figure out what the charge would be for an aluminum ion and figure out what the charge would be for an oxygen ion. This is when we look at our periodic table. We go look at the periodic table. I'm going to pull mine back out.
Aluminum has like +3 and oxygen -3, -2.
Okay, perfect. Thanks, Pawan. So all we have to do, guys, if you guys didn't follow what Pawan was doing, is we go to aluminum, we look at aluminum, aluminum's in group 3 or group 13, and when it forms an ion, it's gonna form an ion with a 3+, and then oxygen, it's in group 6 or group 16, and when it forms an ion, it's gonna form an ion with a 2-. So if I'm writing this, it's saying I have aluminum 3+, that's an aluminum ion. It's gonna come together with an oxygen ion that's O2-. And the whole point of this is that I wanna make the charges go to 0 when they come together. So the way that I do that is I have to figure out how many aluminums I need per oxygen so that the overall charge is 0. So I see that there's a 3, I see that there's a 2. The most common, or the next common number that they have is probably gonna be a 6. And so what I'm saying is, okay, to get to 6+, that means I need 1 more aluminum. So I just write 1 more aluminum now. So now the overall charge on aluminum would be 6+. To get to 6- for oxygen, I need 2 more oxygens. So the overall charge now, when I add them up, is 6-. So 6+ and 6-, they cancel each other out. So now it looks like the ratio needs to be 2 aluminums for every 3 oxygens. So I'd say my formula is I need 2 aluminums for every 3 oxygens.
Professor, I have one question. Like it shows, can you write directly Al, like oxygen's 2 ion is transferred into aluminum and Al2O3, just simply, like a crisscross method?
I think you're saying, can you just look at it and tell? Is that what you're getting at?
By looking, directly.
Yeah,
Crisscross method, cross method.
right. Yes, you can. I just wanted to show everyone why we are doing that. So overall, we want the charge to equal 0. So I have to figure out a way for them to have a common number, and their common number is going to be 6. And an easier way for me to look at that is just saying, okay, I see that there's a 3 right here, there's a 2 right here. If I switch them and put the 2 for the aluminum as a subscript and the 3 for the oxygen as a subscript, I don't bring the charge. I'm not going to bring the positive or negative sign. I'm just switching the number. So I started off with aluminum 3+ and oxygen 2-. When I switch them, I'm going to say Al2O3. Does that
I'm
make
sorry,
sense?
why did we switch them over?
Just an easier way than having to figure out, okay, what's their common number? It's just if you multiply them together, you're just saying, okay, 2 of these and then 3 of these will give me the right number. Because I'm essentially saying 3 times 2 for both of them.
Exactly.
Does it make sense though?
Yes, and does that work, that generally works for all, like,
Ionic compounds, for the most part, yes, but I'm going to give you guys a few examples. So let's do another one. Let's say we're going to do the same thing. We're going to write a formula, but this time we're going to write the formula when a sodium ion and a sulfur ion come together. So here's another example, but this time we have sodium ions are mixed with sulfur ions. And let's see if you guys can do the same thing and come up with a formula. And let me give one more example under here too. All right, so let's do the first one. So what group is sodium in? Let's find sodium on the periodic table. You guys tell me what group sodium's in.
Group 1.
+1?
Okay, it's in group 1, so we have sodium. So that means if it's in group 1, when it forms an ion in group 1, it's gonna have a 1+ charge. All right, then we go to sulfur. What group is sulfur in?
Group 6.
All right, sulfur is in group 6, which is here, group 16. And so sulfur, it's gonna have a 2- charge when it turns into an ion. So basically that's what it's saying. Write a sodium ion, write a sulfur ion, and then connect them together and see what their overall formula is gonna be. Now, right now, the issue is they need to equal 0. And the overall charge, if I add this up right now, +1 and 2-, that does not equal 0. So for them to equal 0, I need to have either, the easiest thing to do, I'm just showing you guys, is that I need to have 1 more sodium to cancel out this 2-. If I have 1 more sodium, where's my other pen? If I have 1 more sodium here, I'm gonna have 2 sodiums with an overall charge of 2+, and then I have 1 sulfur with an overall charge of 2-. So it looks like the ratio is 2 sodiums for every 1 sulfur. I'm gonna end up getting Na2S.
Oh, okay, so it has to equal 0. Okay, now I see.
That's the whole point. You gotta add more elements or more atoms of each element so that the overall charge can equal 0. The easier way to look at that is that, okay, if this is +1 and this is 2-, if I just switch them, it's like I'm multiplying them together. I'm not gonna bring the positive or negative. I'm just gonna say, okay, if this is a 2 up here, that 2 needs to go with sodium, which it did. If this is a 1 right here, that 1 needs to go with sulfur, which is an assumed 1 because I just wrote S. Does that make sense, guys?
Yes.
Okay. All right, so let's do the next one. If I have a calcium ion, what does a calcium ion look like?
Ca2 plus.
Ca2+. Can we see that?
Mhm.
Okay. So Ca2+. If I have an oxygen ion, what would the ion look like for oxygen?
O2-.
Okay, O2-. Does everyone see where I'm getting these charges from? Like, let me know now before I got lots of other steps to do. So if we get stuck on this one, just let me know right now. Calcium's in group 2, you got 2+. Oxygen's in group 6, you just go to where oxygen is and you gotta know that that's 2-. So now we still need the overall charge to equal 0. And in this case, it does. So you have 2 positive and 2-. So all we gotta say is I need 1 calcium, 1 oxygen. Now, you could switch them, like I was saying before, put this 2 here, put that 2 here, and it would say Ca2O2. But when we're writing ionic compounds, we're always gonna write the empirical formula. And remember, the empirical formula is the ratio or the simplified version. So even if you switched it and you got Ca2O2, you gotta remember to go 1 extra step and simplify that to just CaO. And so I'm gonna put a star here and say, ionic compounds always write the empirical formula. And remember, the empirical formula is just the ratio, the simplified version of the formula. I'll say simplified. All right, do I have any questions before I keep going? All right, I'm gonna keep going. So remember when we were looking at the periodic table, this one, and I wrote the ion charge in orange. So that 1+ and 2+, remember I wrote them all in orange, and I said the transition metals, they form multiple ions. And so I can't just assume that, for instance, chromium is gonna have the same ion each time, because I can have a chromium 2+ and I can have a chromium 3+. Same thing with iron. I can have an iron 2+ and an iron 3+. I can have a lead 2+ and lead 4+, tin 2+, tin 4+. So these transition metals, the metals in the middle, they form multiple ions. If you're in group 1, you only form 1 ion that has a 1+. Group 2, you form 1 ion that has a 2+. Group 3, aluminum only forms a 3+. Then here you got 3 minus, 2 minus, 1 minus. All right, and remember it only goes up to like the blue right here. So those can only form one type of ion. Transition metals can form multiple ions. So now we have to talk about how do we name an element that has a compound that has a transition metal in it. So I'm going to say some metals form more than one ion. And those some metals are transition metals. I'm just gonna group them. Transition metals can form more than one ion. Not all of them, but most of them do. There's a table in your book, but I'm gonna give you guys the ones that come up the most in our class. So you can have iron 2+, and the way we write that out is we have to distinguish between iron 3+. So we have to distinguish between iron 3+ and iron 2+, and the way we do that is we write the charge in Roman numerals. So iron 2, we'd say like this. Iron 3, we'd say 1, 2, 3. We can also have cobalt 2+ and cobalt 3+. We'd say cobalt 2, cobalt 3, like this.
How do we know the charges on them?
These are the only charges. So this is what I mean by the transition metals. Like for instance, iron forms 2 types of ions. It forms either an iron 2+, which is missing 2 electrons, or it forms an iron 3+, which is missing 3 electrons. And it just depends on what it's being connected to or what it's being bonded to. So these are only types of ions that iron can form. And I'm just giving you the names of them or how you write out their names. In the formula, I'm going to show you how you figure out which one's which. So we can also have, same thing with chromium, chromium 2, chromium 3, you name them the same way. You got to say chromium 2, chromium 3. Squeeze it all in there, chromium. And then you can also have 10, 2, and 10, 4. These are just the common ones, guys. I'm not going through every single type of ions that transition metals can form. I'm just going with the ones that we're going to use the most in this class. So the way we write the number 4 in Roman numerals is we write I, V. And if you want to make these lowercase, that's fine if they're lowercase as well. We have lead 2 and lead 4. So we'd say LAD 2 and then LAD 4. And then the weird one that comes up is mercury. Mercury looks like this. And instead of saying mercury 2, it's actually mercury 1. And then we also have mercury 2 that looks like this. So the difference is, this one's weird. it's like a little bit of an exception. The way I like to think of it is that there's 2 mercuries. It has an overall 2+. So think of it like each mercury has a 1+ charge. So that's why it's mercury 1. And then there's some transition metals that only form 1 ion. So for instance, I'm just going to write them in red. Zinc 2+. It's always just zinc 2, meaning there's not multiple ions of zinc. It has a fixed charge. It's always going to be zinc 2+. Same thing with silver. Silver is always just going to be silver. You don't have to write these 2 and these 1, so I didn't really mean to write that, so scratch that out. You don't have to write zinc 2, you don't have to write silver 1, because those are the only options that they have.
I have one question.
Yeah.
So zinc has always a fixed 2+ charge.
Yeah.
And how about the silver, Ag?
Always just going to be 1.
Okay.
So these are just a few exceptions for the transition metals.
So zinc doesn't have a Roman numeral, right?
Yeah, it doesn't need a Roman numeral.
Okay.
All right, so now some other ions I want to show you is if you look at the worksheet that I posted on Brightspace, the first one that I'm looking at is the polyatomic ions. It looks like this worksheet. So let's see if we can pull this worksheet up. In a face-to-face setting, I would normally have you guys memorize these, but you're gonna have this at your availability, and I just feel like you just gotta get familiar with them and recognize when you see one. So when you have a polyatomic ion, all polyatomic ion means is that poly means many, and then atom, and then ion. So you have many atoms in an ion. And that's what this worksheet, what this table or what this list is showing us. So remember, an ion means you have a charge, like +1, -1, 1. You see all these charges. These are all ions because they have a charge, 2-, 2-, 3-, 3-. But it's more than one element or more than one atom grouped together. So we call them polyatomic ions. So let me write that down. Polyatomic ions. Polyatomic ions are basically when you have groups of nonmetals combined with an overall charge. So for example, a polyatomic ion that we're going to use a lot in this class is a nitrate ion. It's on that sheet that I just had in front of you. The nitrate ion, which is down here at the bottom. So NO3, 1-. What this is really saying is that I have a group of nonmetals. Nitrogen and oxygen are nonmetals. They're both nonmetals. I have 1 nitrogen, 3 oxygens, and their overall charge is -1. So not just the -1 on the oxygen, it's a -1 on this combined, these combined nonmetals. and this is nitrate. Now we're going to use the polyatomic ions. Nitrate's a good example of one we're going to use a lot of the eights. So if you look at them, most of them end in either ATE or ITE. So like perbromate, bromate, or bromite, or carbonate versus nitrate, nitrite. A lot of them end in either ATE or ITE. And we're gonna use the eights a lot, the ones that end in the ATE a lot. All right, so when you write the formula for ionic compounds that have polyatomic ions in them, you write the formula the exact same way. So for instance, let's say I have a calcium ion mixed with a nitrate ion. I write the formulas the same way. So you guys tell me, what do you think the charge is for a calcium ion? Gotta find calcium on the periodic table.
2 plus.
What is it?
2 plus.
Okay, calcium is in the second group, Ca. And remember, calcium is Ca, it's in group 2. And then when it forms an ion, it's gonna be a 2+ ion. All right. And then when we talk about the nitrate ion, nitrate, we'd have to, if you don't, we're gonna use nitrate a lot, so you guys will probably in about a week or so, have it memorized. But we look at that polyatomic ion table or page and you say, oh, nitrate is just NO3 minus 1. All right. So in this case, how many nitrates do I need to cancel out my calcium?
You need one more?
You need one more. Great. So in this case, if I just add one more down here, and I can still do the same thing. I could still just switch the charges, but I'm just showing you guys I need one more nitrate, or in overall, I need 2 nitrates for every 1 calcium. So I'm saying calcium is 1 nitrate. The way we write 2 nitrates is we have to put it in parentheses and say I need 2 of these. I can't just not put it in parentheses and say 2 outside of this 3, because it's going to assume that I just need 6 oxygens and only 1 nitrogen. But in reality, I need 2 nitrogens and the 6 oxygens. Does that make sense, guys?
Yes.
Okay. Okay, so you guys are following me so far. So even if you have a polyatomic ion like nitrate or any of the rest of them on that worksheet, we're still going to do it the same way, where you can either just switch the charge. Look, I just put the 2 outside of the nitrate, and then I put the 1 outside of the calcium, which you don't have to write the 1. It's an assumed 1 when you write calcium. And in this case, this is the formula for calcium nitrate. So overall, it's just CaNO3 2. So we do it the same way. I just don't want you guys to see more elements and get confused. All right, so do I have any questions before I keep going?
Okay, so for calcium, we're still applying that 2 over to calcium, right? It's just gonna like, what do you call it?
So now, okay, remember this 2+ means that calcium's missing 2 electrons. And this 1- means that nitrate has an extra electron. So now that I have 2 nitrates, that means I have 2 extra electrons, and the nitrates give their 2 extra electrons to calcium. So now they no longer have a charge because they went to 0. So nitrate took its 2 extra electrons, gave it to calcium. Calcium's not missing 2 electrons, and nitrate doesn't have 2 extra. So overall, they're both 0.
Okay.
Does that make sense, Sandra? You need me to say it again? Or anybody, does anybody need me to say that again? I'll just say it again. So remember, this 2+ means I have 2 missing electrons. This 1- means nitrate has 1 extra electron. So if I have 2 nitrates, that means I have now 2 extra electrons. Those 2 extra electrons are donated to the calcium. It no longer is missing 2 electrons. This one no longer has 2 extra electrons. So overall, they're both 0. So you don't have to write this 2+ on top of calcium anymore because it's not missing 2 electrons. It's satisfied when nitrate transferred its electrons to calcium. Hopefully that makes sense. So the same thing happens when you have a transition metal. You still, when you have a transition metal with a positive ion and a negative ion, they come together, you're still just switching the charges, or you're trying to get them overall to equal 0. So this is how you write the formula for all ionic compounds. Now I want to talk about how you name these ionic compounds.
One question I have, Professor. Like there is a ammonia NH3. So how do we know it has a +1 charge or -1 charge, or what? Which charge?
It doesn't have a charge. It's just on that list because it's common. It's NH3 that comes up a lot, but it doesn't have a charge. So don't worry about it. All right. So Sandra, I saw you just logged back on. Hopefully you caught what I said.
It's okay. I'll just go on with it. I'm sorry, my internet was unstable. It's okay.
That's okay.
Yes, I'll just follow along. Sorry.
All right, so what I'm saying is now, this is how you write formulas for all ionic compounds. And now we're gonna talk about how you name these compounds. So naming ionic compounds. And remember, we know it's an ionic compound because most of the time it's gonna have a metal and a non-metal. So for instance, every compound we've talked about so far, calcium's a metal. This is a polyatomic ion, but it still consists of non-metals. All the other examples I gave, it was a metal and a non-metal. Remember, we talked about aluminum and oxygen. Aluminum's a metal, oxygen's a non-metal. So we're gonna know it's an ionic compound because basically we have a metal and a non-metal. And then the way we name ionic compounds, all we have to really do is just add IDE to the end of the second element. But remember, there's 3 different types of ionic compounds. So I'm just gonna write them out right quickly. So let's say, for instance, the first type you have, like aluminum and oxygen. If I have main group cations and anions, or let's say a cation in group 1, 2, and 3. And remember, a cation is basically, I just got a metal. I have a metal from group 1, 2, or 3. So if I have a metal from group 1, 2, or 3, where's my periodic table? So basically, if I have a metal from this group, the first group, the second group, or if I have aluminum, okay? If I have any of those elements, any of those metals, the way I name the polyatomic ion is the way I name the ionic compound is I simply just say, name the metal. I'll say metal name, And then I say, so I'm basically saying the first element, and then I'm saying the second element with an IDE at the end of it. And I'm gonna say, I should say first element up here is what I'm trying to say. So first element, metal name, second element, name, plus the IDE. So what this means, remember the example we did? We said when aluminum ions come together with oxygen ions, they make the formula Al2O3. The way we name this is we say, we name the first element, which is the cation, which is aluminum. And then the second element, we're basically just gonna use the first syllable for it. The second element name is oxide. And if you're confused on how to name these anions or the negative charged ions, if you're confused on how to name those, if we look at the polyatomic ion sheet, I tell you how to name them here at the top. So when you're trying to write oxygen plus IDE, you call it oxide. When you're trying to write sulfur plus IDE, you call it sulfide. Same thing, fluorine, fluoride, chloride, bromide, iodide, nitride, phosphide. So you guys go back to these other ones that we did. What did we do? We did sodium and sulfur, and then calcium and oxygen. See if you can.
Can we say that like a sodium sulfide and calcium oxide?
Ms. Perry, I think you muted yourself.
I think she stepped away.
Never mind.
Okay, what'd you guys say now?
Sodium sulfide and calcium oxide.
Okay, can I get someone to agree with that?
Yeah, I agree.
Okay, good. All right, so remember this formula, if we switch it, Na2S, and we name the first element, which is just sodium, and then we add an IDE to the end of the second element, so it's sodium sulfide. And then when we get down here, it's just gonna be CaO, and we name the first element, which is calcium. And the second element, we add the IDE to the end of it. So calcium oxide.
So we need to put a space between both two.
Yeah, these are two different words. So aluminum and then oxide, sodium and then sulfide, and then calcium and then oxide. So there's a space between each one of those.
Is there any rule like we have to make any capital letter or a small letter?
So I meant to tell you guys this earlier. Anytime you're writing an element name, it's always lowercase. And it only is capital is if it's at the beginning of a sentence. So they're all gonna be lowercase. These aren't like proper nouns or anything. All right, give me like 5 more minutes and then we can take a break, guys. Let me just talk about how we name the other types of ionic compounds. So remember, this is only if your metal is in group 1, 2, or basically aluminum. Now, if your metal is a transition metal, so if your metal, so this is B another way. If your metal is a transition metal, transition metal cation. Remember with the transition metals, where did I put that? Get my paper with the transition metals. All right, remember I wrote out the transition metals for you guys and I said you can have like iron 2, iron 3, you can have cobalt 2, cobalt 3, chromium 2, chromium 3. When you have a transition metal, we're still gonna add IDE to the end of the second element, but for the first element, you have to write the element. So first element, name, and then the charge in Roman numerals. Remember, the charge has got to be in parentheses and Roman numerals. And then we're still going to say the second element with the IDE. First element name, and you would put the charge in Roman numerals. Yeah, that's what I'm looking for. So remember, just like we wrote it here with the transition metals, we're just writing the name, charge in Roman numerals. Writing the name, charge in Roman numerals. So that's all I mean by that. So first element name, charge in Roman numerals, and we're still gonna do the second element plus the IDE. So for example, if I have this type of iron ions coming together with nitrogen ions. First of all, can anyone tell me the correct formula for this?
Fe3N2.
So we say we're just switching, the 2 goes here, the 3 goes there. So Fe3N2, and the way we name this is we have to say that this is iron 2. So it would be iron 2 and then nitride. Basically, we just have to distinguish between iron 2 and iron 3, because you can have an iron 3 nitride, and that's a totally different thing than iron 2 nitride. So you have to say, okay, I'm talking about iron 2 in this case. They have different properties, they react with substances differently. So you have to specify that I'm talking about iron 2 versus iron 3. That's the only difference with the transition metals. You have to put their charge in Roman numerals.
Then why did we change it in the first place? I mean, I know we have to, but I don't understand why we wouldn't do.
This one right here gave the overall formula for the compound. This is saying if I mix together iron 2 ions plus nitrogen ions, it's saying if I like put them in a cup and I mix them together, what compound are they going to form? This is the compound that they form.
Okay.
3 irons for every 2 nitrogens so that they can cancel each other's charge out.
Okay.
And then this is just saying this is how we name it. So if I do another example, let's say I have iron like this, and then this, you guys tell me, well, write it yourself. Don't call it out your shit. So write the formula and then write the name. All right. What do you guys think this one is? The formula first.
FeCl3.
FeCl3. Somebody else tell me what you think the name is.
Iron 3 chloride.
Iron 3 chloride. All right, somebody else tell me what the formula is for this last one.
It's gonna be Fe2,
Okay, keep going.
and then it's gonna be O2.
All right, so then
Or
remember,
do they cancel out? I'm sorry, I think they cancel out, so it's gonna be FeO.
perfect, thank you. I'm glad you talked yourself through that. So FeO, but yes, you could say Fe2O2, and then you just have to recognize they cancel each other out. You can simplify it to just FeO. So how would we name this one?
Iron 2 oxide.
Iron 2 oxide. Now, it's clear when you have the charges here written, because you see that this is iron 2, this is iron 3, this is iron 2. But if I just have the formula written and I say write the name, it's not always that clear, because you're like, oh, how am I supposed to know that this is iron 2 versus iron 3? And the way that you figure it out is because oxygen is always going to be 2 minus, because it only forms one ion, which is O2 minus. So if oxygen is always 2 minus, that means iron must be 2 plus for it to cancel each other out. And if you look at this one, it's saying chlorine is in group 7. It's always going to be -1. So if this is chlorine -1, the fact that I have 3 of them means that this must have been iron 3. Nitrogen's always going to be -3. The fact that I have 2 of these means that this must have been iron 2. We kind of have to work backwards is what I'm saying. Okay, I'm not gonna, in class, if we were face to face, I'd stress a little more about this, but I just wanna make sure you guys, the only difference between transition metals and group 1 and 2 metals is that you just gotta write the charge in Roman numerals for the transition metals to distinguish them from each other. And then the last one, when you talk about the polyatomic ions, you just got to name the polyatomic ion wherever you see it. So remember, the polyatomic ion is that page that I made you guys just pull up. So for instance, with the nitrate, whenever you're naming polyatomic ions, let's say your ionic compound contains a polyatomic ion in your ionic compound. The way you name these, you just name the polyatomic ion wherever you see it. So if you see the polyatomic ion first, you say name of polyatomic ion. And then you say second element with the IDE still. But most of the time, your polyatomic ion is going to be second, and that's because most of the polyatomic ions are negative. So because they are negative, you always write the positive sign first. If you notice, we always write the positive sign first and then the negative sign. So if we look at most of these polyatomic ions, they have a negative charge. There's like 2 or 3 that have a positive charge. These 2 over here have positive charges, but most of them are negative. So most of the time, your polyatomic ion is going to be second. And if your polyatomic ion is second, we're still going to say first element name. And then we name the then I'll say name of polyatomic ion. So even if your polyatomic ion is second, you don't add the IDE to the end of it. You just name your polyatomic ion. So let me give you some quick examples. So for instance, if I have magnesium ions that are going to be mixed with nitrate ions, when I go to write the formula, once again, I'm just going to switch the charges or recognize that I need 2 nitrate ions for every 1 magnesium. So it's going to say MgNO3 2 like this, but the way we name this, my first element name is magnesium, and then I name the polyatomic ion, so it's just magnesium nitrate. So Mg2 plus, and then nitrate, which is NO3 minus. When these 2 ions are mixed together, they form magnesium nitrate. 7. All right, so another example would be if I have, for instance, NH4 ions, which is ammonium, and then I have chloride ions. So we have to look at this polyatomic ion sheet, and most of the time, you guys, if it's more than 1 element, you got to recognize that it's going to be a polyatomic ion. So you got to look at the sheet, go find the NH4 plus. The NH4 plus is ammonium. So since the polyatomic ion comes first, I just name the polyatomic ion, but then I got to remember to put the IDE at the end of the second element. So this is going to be ammonium, and then chloride. And if I write the formula, sorry, the formula is still just going to be NH4Cl. It's +1, -1, so they cancel each other out. And then I'll give you guys one more and see if you guys can get this together. Let's say I have an iron ion that looks like this. And then I have a nitrate ion that looks like this. Let's see if we can write the formula and name this compound. All right, what do you guys think the formula is for this compound?
Fe, inside the bracket NO3, and outside there is 2.
Yep, that's correct. You see, we need 2 negative charges for every one of these 2 plus charges, so it's equals 0. So we write it like this. We got to remember to put it in parentheses, because if we don't put it in parentheses, you're not going to recognize that this 2 distributes to the nitrogen and the oxygen. And when we go to write the formula, can somebody else tell me what the name is?
Iron nitrate.
Okay, but iron what?
Oh, iron 2.
Yeah.
Roman numeral 2.
Yep, we just got to remember to say iron 2 nitrate, because iron is a transition metal and it can form iron 2 or iron 3. So we got to remember to say iron 2. Okay, thanks, Eve. I see. All right, do you have any questions before we take a break?
Can you just really quickly remind why NO3 is called nitrate? Is that because it's an oxygen and nitrogen?
Nope, it's a polyatomic ion, and it's on this handout that I posted on Brightspace. So if you look at the chapter 5 worksheets that I posted, it's one of them. It's some non-metals come together and form a group, and their overall charge is, they still have an overall charge. So we polyatomic ions, they have many atoms in their ions, and
Okay.
nitrate is a polyatomic ion. So we just got to get familiar with these.
Okay, I see it now.
Okay, so if I don't have any other questions, let's take a break. And I did the hard ones first. So when I come back, we'll do the easy ones. So if we get this part, the rest of the lecture is easy. All right, any questions? All right, well, let's take a break. You guys want 10 or 15 minutes?
15.
15, okay. I make my daughter sit here and take notes with us, and she's whispering, 15, 15. All right, I'll see you guys in 15.
All right, sounds good.
All right, guys, let's talk through it. All right, can we say what the first element is?
Lithium sulfide.
Okay, lithium sulfide. Perfect. Let me write the answers in a different color. What about number 2?
Potassium fluoride.
All right, great. Potassium fluoride. Number 3.
Is that Magnesium Two Nitrate?
Okay, so the only time you have to put the Roman numerals, like the 2 or the 3, is when you have a transition metal. And remember that magnesium is in group 2. Where's my periodic table? So magnesium is here in the second column, so it's always going to be 2+. You don't have to put the 2 in parentheses. You just say magnesium, and in this case, this is nitride, so we just say magnesium nitride. So yes, but just you don't have to put the 2 in the middle.
I'm sorry, what are the transition metals again?
Remember, those are the ones in the middle. So the ones that are like here to here or so.
Okay,
Yeah.
okay, I see.
Remember, we mainly talk about the first group, the second group, and then we skip over 3, 4, 5, 6, 7, and 8.
Okay.
What about number 4? What did you guys get?
Is it
Hydroxide.
calcium 2 hydroxide?
Remember, you don't have to put the 2, even though it has a 2+ charge. When you think of it as an ion, because it's in group 2, you only have to put the 2 for the transition metals.
Okay. Okay.
So just calcium hydroxide.
Calcium hydroxide. Okay.
What about number 5, guys?
Barium nitrate.
Barium nitrate. So yeah, barium's past number 36. So I wouldn't have you guys memorize that, but BA is barium. Now for that's number 5. Number 6, copper is a transition metal. So we'd have to say which copper we're talking about. So what copper is this?
Copper 2.
2.
Copper 2.
Yep, it's
All
copper.
right.
And we know it's copper 2, mainly
Oh,
because chlorine's always going to be -1 because it's in group 7. But also we could just see, okay, if we switched charge to get this 2, we could just switch it back and assume that that's copper 2. So this is copper 2 chloride.
Okay.
All right, so that's copper 2 chloride. Now this one's a little tricky. All right, can you guys tell what this is? Remember, lead's a transition metal, so it's going to be lead something. What is it? Lead what?
Lead 2.
Lead 2. And I didn't mean to say it's tricky. I'm just saying that we have to recognize, even though there's no 2 here for this oxygen, we have to know that oxygen is in group 6. So if oxygen's in group 6, that means it's 2-. So this lead must be 2+. So it's lead 2 oxide. Yes, this is nitrate. Thank you, Eve or Diana. Diana just corrected me for number 5. This is nitrate, not nitrite. So it should end in ATE, not ITE. And then we get to number 8. Number 8, what do you guys think it is?
Zinc 2 fluoride.
All right, now I wouldn't mark this wrong, but remember zinc is one of those exceptions to where you don't even have to write here. Remember how I wrote zinc here? You don't have to write the Roman numeral 2, you just say zinc. So it's technically just zinc fluoride, but if you put zinc 2, I'm not upset with that. You got the whole point of it. What about number 9?
Sodium acetate.
Sodium acetate, perfect. And guys, when we look at acetate on the polyatomic ion sheet that I gave you, there's 2 formulas for acetate. They're the exact same formula. So I'm saying right here, it says acetate written like this, and then it has it in parentheses like this. They mean the same thing. The only difference is one kind of tells you how it's laid out. So this one is the condensed version. So you see there's still 2 carbons. So you write C2, there's still 3 hydrogens, and then there's 2 oxygens. So this one just in parentheses, put it all together. The top one is still acetate. And then number 10, what do you guys get?
Strontium carbonate.
Perfect, strontium carbonate. So strontium carbonate, and then what about number 11?
Chromium 2 sulfate.
Chromium.
4 sulfate. I think.
Oh, chromium 4. Oops.
Wait. No. You guys, you were right. It's chromium 2. Remember, SO4 is technically just the formula for sulfate.
Oh, okay. Thank God.
So don't look at that 4 and assume that it's chromium 4. The SO4 is the overall formula for sulfate. And sulfate is SO4 2 minus, so this must be 2 plus, so you were right. It's chromium 2 sulfate. That's a common mistake. You guys look at this 4 and you say chromium 4.
It's called
Okay, so what about number 12, guys?
Sodium phosphate.
Sodium phosphate. Okay, it sounds like you guys got it, but let me know if you guys have any questions.
Will most polyatomic ions be given? Like,
So no, I'm not gonna give you any of them. And like I said, I mean, you guys are gonna just have your stuff with you. I can't see what you're looking at. So normally, like on the next quiz or test, I would have you guys have it in class and you'd have to like name, I'd give you like a list of compounds like this and I'd say name them, but you wouldn't have anything to work off of. I'm just gonna assume that you guys are always gonna have something to work off of since you're sitting at home, and I probably won't focus so much on, you know, giving you any polyatomic ions just because you can always just look on your sheet. But the common ones that we're gonna use are like the ones on this, where'd my worksheet go? The ones on the tape, on this table here. These are common ones that are gonna come up a lot, especially like hydroxide, nitrate, acetate, sulfate, carbonate. Those are gonna come up a lot. And so you'll just kind of get used to seeing it. And my main point is that you are able to recognize, because a lot of times you guys will see like for this barium nitrate, you guys will say barium dinitrogen trioxide. And it's like, no, you got to recognize that NO3 is nitrate. So it's just barium nitrate.
Can we do that like with the periodic table? Like, can you not put the periodic table on every page of the exam?
So what are you saying?
I found it frustrating to have to stroll up and down. I felt like I was losing a lot of time with that periodic table on every page.
Okay, that's fine. I don't have a problem not putting it out. I just didn't want you to spend a lot of time looking for the periodic table, and I always wanted you to be able to look up above each question. I can put it just like as at the beginning of the test and then at the end of the test or the quiz. I don't have to put it on every page. And then the other thing is, you can click, when you're taking the quiz, you can click on each page so you don't have to keep scrolling up and down. You can click on like page 1, page 2, page 3. I had it set up to where you can, at the beginning of each page, it was there for you. Not necessarily like every 3 questions, if that makes sense. All right. Yep, go ahead, Adriana.
Good question. How would I know between like number 1 that it's just LiS lithium sulfate, and then number 11 is SO and it's sulfate?
So this one ends in IDE, and anytime it's in IDE, it's just that non-metal. Like sulfur, when you write it as a name, you say sulfide. So remember here on the top of this polyatomic ion sheet, I give you the names of the non